Calculus, video 26, combining the rules for derivatives. So here's our rules for derivatives so far. We have that the derivative of a constant is always 0. We have the power rule next, that the derivative of a times x to the n is a times n x to the n minus 1. And thirdly, we have the derivative of e to the x is itself e to the x. Then on the right here, we have the product rule. The derivative of two functions multiplied f of x times g of x is f prime of x g of x plus f of x g prime of x. And then finally, we learned the quotient rule. The derivative of f of x divided by g of x is f prime of x g of x minus f of x g prime of x divided by g of x squared. The numerator of which is a lot like the product rule, except for it's minus instead of plus. What we want to see today is there are times, quite often in fact, where we combine a lot of these rules together. It's not just going to be the product rule and that's it, or the quotient rule and that's it. There are times when we have a quotient rule and in the numerator there's a product. So we have to use a product rule within the quotient rule, right? So let's give an example of one of those kind of instances where we are combining the derivative rules. So this is a function 4x e to the x times x squared plus 1. And at first look, you might say that is a quotient rule. And you'd be partially right. It is a quotient rule. You have a function in the numerator, you have a function in the denominator. But in the numerator, there's actually two functions. You have your 4x function, and you have your e to the x function. That's two functions. So in the numerator, when you do the derivative of the numerator, that f prime that we've been used to, that's actually going to be a product rule. Okay, so let's give it a shot. We remember that h prime of x is equal to f prime of x g of x minus f of x g prime of x over g of x squared, right, where the f function is the numerator, f of x is the numerator, and g of x is the denominator. Okay, so let's try it out. The first thing we have to do is f prime of x, the derivative of the numerator. But the numerator consists of two functions being multiplied. So in order to do f prime of x, just to do this part right here, that requires a product rule. The derivative of f, the derivative of the numerator, which consists of two functions, we have to use the product rule just to get f prime of x. So here we go. H prime of x is equal to f prime of x. But f prime of x is product rule, the derivative of 4x, 4, times leave the e to the x, that's the g function, well, that's the second part of the product rule, plus, I really didn't want to put that parentheses there, plus, leave the first function 4x times the derivative of the second function e to the x, which in this case the derivative of e to the x is just e to the x. That whole thing right there, that's f prime. That's the derivative of the numerator using the product rule to get there. That is f prime. You know what the most missed part of this problem is? People do the f prime. They see the product rule, they work through all that, and then they forget they need to multiply f prime by g of x, the denominator of the original problem. So times g, which is x squared plus 1. That's the g function. Minus, now we're going to leave the f function itself. We don't have to do product rule because we're not multiplying. We're not actually taking the derivative. Right? We're not taking the derivative of the f of x. We're just having f of x itself. Times, so that's just f, times g prime. What is the derivative of the denominator, x squared plus 1? That's 2x, all divided by x squared plus 1 squared. So what we've done here is we've done the quotient rule, but within the quotient rule, we have this section right here, which is the product rule of f prime of x. It's the product rule for our numerator because our numerator was two functions multiplied together. All right, So now we'll take that and we will distribute. We'll take this x squared here times this one and times that one. We'll take the 1 times this one and times that one. The 2x will just get multiplied in there. And simplifying, we have this. We have 4x squared e to the x. That's the x squared times 4 e to the x. Plus x squared times 4x e to the x would be 4x cubed e to the x. Then distributing the 1 times 4 e to the x would be 4 e to the x. And 1 times 4x e to the x would be 4x e to the x. That's that distribution. Minus, no pluses and minuses, so there's no distributing here. There's just 2x times 4x e to the x. That would be 8x squared e to the x. All divided by, don't forget this part either, x squared plus 1 squared. Let's see if anything can combine here. The x term with the largest degree I'm seeing right here is this one. I have 4x cubed. I don't see any other x cubes around. So I'm just going to write that as 4x cubed e to the x. Okay, let's see. We have now a 4x squared e to the x and a negative 8x squared e to the x. So that would be minus 4x squared e to the x. And then I have a plus 4x e to the x. I don't see anything else to combine with that. And I have a 4e to the x here plus 4e to the x. Nothing to combine there. Over x squared plus 1 squared. You'd be surprised how many students lose the denominator halfway through the problem. Just forget to write it. Let's see if we can combine it all here, simplify. Each of the numerator terms have a 4. Each of them have an e to the x. Let's take out a 4e to the x. That leaves me with x cubed minus x squared plus x plus 1 divided by x squared plus 1 squared. And I think that's it. All right, so there's an example where we took the derivative. This one happened to be a quotient rule, but within the quotient rule needed to use a product rule. You'll see all different kinds where we take a product rule, and within the product rule we have to use the quotient rule. Or we use the e to the x, derivative here as well in this case. You're using several rules at once a lot of times.